Good morning, everyone. Welcome to the Marine Biodiversity Networking Friday. I'm going to be your moderator. My name's Kendra Daly. I'm a professor at the University of South Florida in the United States. And I guess we'll wait a minute for everyone to get into the webinar. Okay, I've been given the go-ahead to start. And again, for those of you just arriving, welcome to the Marine Biodiversity Networking Friday. My name's Kendra Daly. I'm a professor at the University of South Florida in the United States, and I'll be your moderator. So we'll be hearing a very interesting talk today. But if you should have any questions, please put them in the question and answer in the Zoom section or in chat, whichever you prefer. It's my honor today to present our speaker, Hauke Flores. He's a polar researcher and a marine biologist. He currently works at the Alfred Wegener Institute, Helmholtz Center for Polar and Marine Research in Bremerhaven, Germany. He received his PhD at the University of Groningen. Did I butcher that? Okay. I was practicing my pronunciation last night in 2009. He has participated in 13 international expeditions to the Arctic and the Antarctic. He's published more than 50 scientific papers on the polar systems, and he is a valued member of various national and international advisory groups and working groups. So his talk today is on the Weddell Sea Observatory of Biodiversity and Ecosystem Change, called WOBEC. I love the name. So obviously it's on the Eastern Weddell Sea, which is a very undersampled, underrepresented, but valuable ecosystem in today's global ocean. So with that, I'd like to present Dr. Flores.
Thank you, Kendra. That was a very kind introduction. And I feel very honored because that acronym was actually my idea back when we wrote the proposal with a big group. I can just get started right away. Before I get started, I would like to thank the Ambon community for having me. It's, for me, again, a great honor to speak here. And I'm really thankful, actually, to make WOBEC known outside the Antarctic scientific community and being a bit broader, and particularly, as you will learn during the talk, regarding the sharing and making accessible of data from the Antarctic. So I hope you see the presentation now. As said, I will introduce to you the Weddell Sea Observatory of Biodiversity and Ecosystem Change. This is a project that was funded under the umbrella of the EU Biodiversa program. It's an umbrella that brings national funding together to make broader projects on European and international level possible that specifically deal with biodiversity and biodiversity-related stakeholder interaction worldwide, but of course with a European focus. So just this week, I came across a very interesting publication of people who were finding what was like the big missing link that many of us, and also me, have probably been looking for since their youth, in how on earth, literally how on earth, does the step from chemistry to science happen? How did it happen back in evolution? And apparently now we have a much better view of how this may be possible by self-reproducing RNA molecules. I wonder what this has to do with Antarctica, but I'll tell you soon. There was one little side aspect in this publication which made me particularly excited, and that is that the people who did the experiments to prove that RNA can actually reproduce by itself made the experiments in cold conditions in ice, showing that particularly in the frozen saline environment is where these kind of reactions are easily happening. And I think that just brings another very important perspective on the role of biodiversity in ice-covered regions on this planet. And this, as many of us probably also know, is that particularly these ice-covered regions on Earth are changing. They're changing rapidly due to the climate crisis. And for a long time, we have thought that we've seen that the Arctic Ocean has changed tremendously, losing more than 50% of its sea ice coverage in summertime. And for a long time, we thought this would not happen so soon in the Antarctic, but since about 10 years, we've seen also a decline of the Antarctic sea ice coverage that has so far not coming back to the previous levels. So not surprisingly, when you warm up a planet, then the ice-covered regions will be affected first, and that's what's not only happening in the north, it's now also happening in the south. So these changes in the physical systems, they will inevitably also call up changes in the ecosystem. And this is something that the scientific community working in the Southern Ocean has been thinking about for quite some time now. And in the year 2022, Julian Gutt and many colleagues published a paper highlighting the need for long-term observatories in order to track this, to monitor the changes and to understand the changes that are about to happen in the Southern Ocean. And they put a particularly emphasis on the need to establish such observing systems in the Eastern Antarctic domain, to which a large part of the Weddell Sea belongs. So they stated that long-term data availability and ecosystem understanding are imperative to determine, understand, and project the consequences of climate change and support sound science-informed management in the Southern Ocean. So many of us thought that's actually a very timely paper, and it put very nicely out there what really needed to be happening, and particularly to give you some personal perspective. For me, I have been coming to RV and only at that time being exposed to work in the Arctic Ocean, and there we realized that the moment that we started to do science, ecosystem science, particularly in the Arctic Ocean, the system had already changed from its previous pre-industrial stage dramatically. So we don't even have a baseline in the Arctic Ocean, to be honest. And we did not want to have this to happen in the Southern Ocean too. So we basically came together with a group of well-known colleagues and friends and thought we need to do something about it. And when the biodiversity call came out, asking specifically for establishing long-term observatories with strong stakeholder involvement, we thought this is a good moment and maybe a good way to ask for money in order to conduct the research that is necessary to do this. And we came together with 11 institutions out of 9 different countries. 7 of them were in the EU, and then there's 2 institutes in Norway and the Antarctic and Southern Ocean Coalition, which is based in Washington, D.C. in the US. So then we thought, okay, where shall we actually do long-term observations in East Antarctica? And we relatively quickly zoomed in the Eastern Weddell Sea because it is basically untouched. It's a near pristine environment. It is reaching far south and therefore is a possible refuge for many Antarctic marine and cold-adapted species. And it also features all the habitats that are representative of the large Eastern Antarctic realm. Reaching from the coast to the deep sea, it even has a famous seamount, Maud Rice, and has is annually pack ice covered. And you can sample the pelagic system and the seafloor as well. And at the time when we wrote the project, there was still not a lot of visible environmental and ecological change happening in that area. That's why we thought it would probably be good for baseline. One thing is not on this slide, but it's also important, is that it features a ghost ship transect at 0 degrees. I hope you can see my mouse arrow here. And this transect has also been sampled a long time, mainly for physical oceanography by the Alfred Wegener Institute. So there is already some data from that region that we can also use to look into the past. So what we were thinking of getting done there was to get not an observatory, not a big long-term monitoring site, because for that the biodiversity funds are far too little. So you cannot deploy all the moorings and ships and everything you would need to make this happen, let alone the staff costs that are involved with such a thing. But we thought, let's get started and investigate how this could and should be done, and basically develop the DNA of a long-term observatory in the Eastern Weddell Sea. A DNA in the sense that we set out data and rules and procedures that can be used and can also be copycatted by anyone else in order to increase the chance that that sampling will be done there over years and decades to come. And this observatory, in our view, has 3 cores. One is to actually go in the field and do the sampling, do this in a smart way using advanced technology, to speak with our stakeholders about what is actually important to sample and where and how, in the sense that it would be most useful for the global society and the different actors that it has. And maybe the most important part is that data from that region should be publicly available and fair in order to actually allow cross-disciplinary and long-term comparisons, and also, of course, circum-Antarctic comparisons. So to spell this out, our objectives are to co-design a WOBEC monitoring framework with stakeholders. That might be the Convention for the Conservation of Antarctic Marine Living Resources, CAMLA, but also the fishing industry, the tourism industry, and scientific stakeholders such as SCAR. We would develop and apply a multi-scale monitoring strategy that integrates established methods with advancing technology, and we would make Eastern Weddell Sea biodiversity and ecosystem knowledge, including the underlying data, publicly accessible. So those were or are our ambitious objectives. I will now briefly describe each of them and then tell a bit more about our data approach, because that has, I think, the most connection to MBON. So first of all, and above all, we would like to speak to the stakeholders and about what they would like to know from this area. For that, we develop a knowledge co-production protocol together with them. We have already held 2 very interesting and successful stakeholder workshops where we expose them to problems that are in this area and also ask their opinions about which kind of data to collect and where. We are using Earth observation by satellite because that's a very nice tool to get a quick overview of the patterns in the region and also to communicate with the stakeholders. And we will want to use, finally, in the end, the knowledge that we gain out of WOBEC and out of the stakeholder process in particular to enable decision-making under deep uncertainty that will help to develop management actions under various scenarios. Because one thing is for sure is that we will not be able to tell for sure what's going to happen with all these big changes that are happening in the Southern Ocean. And obviously, stakeholder work needs good communication and outreach into the society, and today is maybe a part of that communication and outreach plan as well. So when we look into the observations, what we do, I already said that these should be multi-scale, and this picture shows the example of the sea ice habitat, and it shows different devices that are being used, and each of these devices has a different footprint in time and space. And the really difficult task, I think, is to design the sampling with different devices in such a way that they are complementing each other in their temporal and spatial resolution. Just to show you maybe my drawing is not that perfect. So here's an ROV, here's a sea ice buoy with a built-in echo sounder looking downwards. Here's an under ice trawl that can sample krill under the sea ice, but also measure sea ice properties. And here's a little ship with an echo sounder and a towed net. So basically what we have to look at the data that all these devices can produce and basically plot them in this time by space plots and see that they hopefully are not all separate from each other, these little circles, but eventually they will overlap in some time in some way so that we get a good sampling of the area, but also of the seasonal and interannual processes. And as I said, data is a big part in WOBEC. And it all started obviously with a data management plan that was made at the start of the project and is still being updated. You can download and see the data management plan on Zenodo. And if you scan this QR code, it will directly guide you there. And the overarching goal of our data management is to make historic and recent and new data sets available to everyone. And for that, we specify a workflow from relevant data sets up to the essential variables that we are identifying in WOBEC. And very importantly, we will want to work towards unified data standards in order to enable circumpolar comparisons. For all that, we also need to develop standard operating procedures that we will apply or we would like to apply in the field so that the data in the end becomes comparable. And obviously, it is very important to put the data that are collected in the WOBEC project into a global context and again make them comparable. And for that, we have adopted the concepts of essential ocean variables and essential biodiversity variables. This graph is probably a bit hard to see every single parameter. This is a selection of parameters that we have chosen to be important. But what is important to know from this slide is that we are mapping every single parameter that we collect within WOBEC onto these essential variable concepts so that we can talk about them and exchange them also with other initiatives and in time in the future, hopefully, other initiatives such as Antarctica InSync, for example. And we would also like to make accessible to everyone what specifically we consider WOBEC data and make it possible to actually find them. For that, we are currently building a metadata portal. It's not online yet, but the picture here shows you a screenshot of its current state. And this is built on a GeoNetwork, and we built it in such a way, actually not we, it's Thomas Vandenberge from Belgium who has created this. And he started by harvesting data that are already there and that fulfill certain criteria that make them eligible to our WOBEC project, mainly geographic provenance, but also other criteria. And it will also be able to ingest new data that we are collecting within WOBEC, and it uses machine learning techniques to filter down and make sure that the data, that it's not just showing everything of everything, but really allows us a targeted overview of the data that we want to involve in WOBEC. As a part of the stakeholder process, Eleanor Campbell from Stockholm University developed a Shiny app where we can visualize data that are available, in this example mainly from Copernicus, but we can also show species distribution data from OBIS and so on. And this is has proven to be a very insightful tool in the stakeholder workshop, because we can see what's going on. On this example that I'm showing here, this screenshot, we can see on the left side the change of chlorophyll between the period of 1998 to 2006 versus 2016 to 2024. And we see that it's quite a divergent pattern in our area of interest. And on the right side, we see the change in the sea ice coverage or the days of sea ice coverage between comparing these same two periods. And we see that our area has already been heavily affected by losing sea ice. Yes, and then just a couple of months ago, we put all these ambitions that we have made to a reality check and went out on an expedition to the Southern Ocean, to the WOBEC area, which was obviously called the WOBEC expedition, Polarstern Cruise 152, from mid-December to early February. On the top right, bottom right, you see the whole science crew that was on board. And the objectives of this expedition were to provide a baseline of biodiversity and ecosystem in the Eastern Weddell Sea against which change can be measured, to study key variables and of carbon and nutrient fluxes, as well as key species that are involved in these fluxes. And last but not least, to ground truth autonomous sampling devices for key biological variables studied as essential biodiversity variables. By ground truthing autonomous sampling devices, we mean that we are increasingly using autonomous eDNA samplers, optical, video optical and imaging optical devices, and echo sounders to increase the spatial resolution, but also to leave things on moorings and at buoys to survey the area over longer timescales. But in order to understand what these data tell us, we also need traditional gear to make up the comparisons, particularly when it comes to taxonomic resolution, for example. So here's the research area that we covered during this expedition. On the left side, you see the Cap Norvegia region in the Southern Weddell Sea. If you look at the kilometer or the mile scale here, you see that it's covered, this map covers a much smaller region than the one to the right. And here we could sample the ecosystem basically from shallow waters into the deep sea along two transects. And on the right-hand side, we see the prime meridian region, which was mainly for pelagic samples, but also we sampled the seamount Maud Rise where we made benthic and pelagic stations and again sampled the system from the surface to the seafloor. Here are some examples of gears sampling that has been done during that expedition. On the very top of the ship, we had bird and mammal observers who were more or less continuously censusing the life of warm-blooded animals. We had a CTD, which takes water samples, surface and under ice trawl, which samples animals living under the sea ice. We performed several ice stations. We had this gear called OFOBS, Ocean Floor Observation and Bathymetry System, that makes video transects of the benthic megafauna, and we deployed several buoys and serviced moorings. Here's just an example of these great imaging capabilities that we have nowadays, and we hope in the future will largely replace invasive bottom sampling. These are pictures from the OFOBs from the seafloor near Cap Norvegia. You see nicely these sponges, communities, bryozoans, and echinoderms here. And if these pictures are such a high resolution that you can zoom in endlessly if you want to really find out who lives there. And our hope is that by repeating transects with this device, we can get a track record of changes or not changes in that area. A very important aspect of our approach is to increasingly use autonomous devices. This is an example of an autonomous sea ice buoy that is equipped with an echo sounder. The example I'm showing here is a buoy that we have deployed years ago in the Arctic Ocean, just showing that this concept worked. It has already been published. We were taking almost an identical buoy to the WOBEC area this year, but the sea ice proved to be not stable enough, so we brought it back, and we will put it hopefully on the next WOBEC expedition. And just to zoom a little bit into the work that we've been doing in my group, we've been focusing on the pelagic system and some sea ice work in some part. And the pelagic system was monitored in first instance by an EK80 echo sounder that was practically running continuously. And we tried to ground truth what this echo sounder sees by rectangular mid-water trawl catches that catch krill and other macrozooplankton and small fish that live in the water. And also we were looking at the very surface layer at the ocean with the surface and under ice trawl. And altogether, we think that this will give us a very comprehensive picture of the pelagic community, and will also allow us to couple this to things like autonomous buoys, which have only echo sounders but no nets. Here's some impression how this all looks in real life. You see that the RMT here on the left is really not that small. It's quite a big net. And on the right side of this slide, you see some pictures of how the work looks on board, and also how beautiful these animals are that are sampled by the RMT. So we tried to gain some first insight into the pelagic food web, and very important for this is really the echo sounder, because our nets can only sample every here and there, with sometimes large distances between them. And only the echo sounder gives us a continuous record of the distribution of life in the water column. And in the top row of this slides, you see some of the animals that have a backscatter signal that we can see with the echo sounder, although we can actually not really distinguish them. And on the bottom of this slide, you see on the right-hand side a typical echogram, where you can see how the transition from day to night, and in the night where you see a lot of zooplankton raising from deep waters up to the surface. And on the left side, you see integrated data of the acoustic backscatter along the zero meridian between 61 and 68 degrees south. And these backscatter values are really, really low. So we were really wondering what is happening there. And we've been there 4 years before, and already then thought there was very little krill in the water. But in 2022, there was almost twice as much backscatter in the water than this year. These are all raw data, and I'm not showing them to you as being scientific results, but as an example of what makes us think and why we think it's important to observe this region. Seeing these low abundances of krill, which were also in the nets, sometimes only a handful of animals rather than buckets full of, as you would have expected. And noticing that the sea ice has been very low in the past decade already, there are hypotheses out there that the system may change from a krill-dominated to gelatinous animals-dominated systems. Things we cannot say after one expeditions, but things you can say when you do repeated observations of the same system. And that's why we think it's really important to have this recurring monitoring in that area. WOBEC, as I said, is also engaging in outreach, and the outreach on this expedition, I would say, was a particular success. And also, I think it was really important. So we made a lot of TV and radio interviews. We had a social media channel active, and we did several schools, classrooms live from the ship. This was possible due to the fact that we decided to take a specialized media person on board and one on land. So 2 people only doing this, but we think it is extremely important because for this kind of research, we need societal support, and we also want our results and our experiences not to be only on our hard disks and in our drawers, but we want to share them with at least those people in the world who are interested. And you should not need to have a PhD in order to see what we are doing. So as a take-home message about WOBEC, we want to create the DNA of a long-term observatory, which is independent of national funding priorities. That there, for the DNA concept, everybody can take this up and ask for funding and go into the area and sample according to the principles that are set out in WOBEC. We want to co-design the monitoring framework together with stakeholders. We want to implement scale-bridging sampling to understand spatial, seasonal, and inter-annual variability. And we want to make as much data as possible publicly available and fair. So with regard to the Ambon community, I would like to highlight that WOBEC is engaging in essential ocean variables and essential biodiversity variables, and we would like to learn and interact about them and to broaden our view and our understanding of how these can be applied. We are very interested in stakeholder-oriented data projects, and that's maybe something we can talk about together. We can also provide a hub to unique Antarctic biodiversity data, because that's our goal, to actually bring all these data together. And we are still looking for partners to make this WOBEC a long-term success. And maybe we can contribute to the development of a future Antarctic bond, which we see has already been taken the first steps to by collaborations of Ambon with SCAR and Biodiversity.AQ, the latter being part of WOBEC in the same persons. So yeah, if you want to learn more about us, visit the website, visit us on Instagram. We also have a very interesting fact sheet that we are happy to share. With that, I would like to finish this talk and thank you for your attention.
Thank you for such an interesting talk. It's exciting to see the Weddell again. We have one question on the Q&A. It's a very long question, and it may be that you want to continue this conversation with this particular person outside of this webinar. But Hossein Nabhani from Morocco is developing a marine observatory in the Mediterranean. And he's interested in knowing what types of support or collaboration mechanisms could benefit within these initiatives, both scientific and methodological guidance, data interoperability, training, capacity building. So their group is very interested in exploring how emerging observatories in regions like North Africa could connect with these global initiatives.
I think, well, first of all, I invite you to email me directly because I think we have a lot to talk about together. There is an emerging global. No, we start differently. In my experience, just in the past 5 years, I would say the observing community has made a change of mind, and people are working together much more, realizing that we need to build large networks, starting from the regional scale. In my case, that's the Arctic and the Antarctic, which are already big regions by themselves. So you need to build networks inside them and then connecting those globally. And I think the capacity building part, data standards, particularly concepts of essential variables, are the key to making all these initiatives globally connected, because that, I think, should be the ultimate goal of us, to make our observations so compatible that we have a global view on at least some of the aspects of biodiversity. So by all means, contact me. You can always, when we have a project meeting, which will probably be at the beginning of next year's, we will invite guests, so you can put yourselves on a guest list. And there's also a meeting by the Biodiversa network in the beginning of May that I can share with you if you contact me. That may be interesting to register to.
All right. So you have a number of people responding. That was fabulous talk, great top, amazing job. There is another question. Juice Pompert asked, did you find any ice fish nests active or abandoned?
We did. This year they were all abandoned. They might have been abandoned after last season already. 4 years ago, I showed you some data from 22 when we already actually did a first secret pilot study. We found them also active.
All right, I have a question. Where do you find ice fish nests?
Well, I know that you are very familiar with Antarctic research, Kendra, so I don't need to explain to you what ice fish are, I think. And they they actually breed on the seafloor, on the shelf. And there has been quite fascinating publications where they have first been discovered breeding in the southwestern Weddell Sea. With also OFOPS, the same device, same guy, Orton Purser. And then 4 years ago, when we went into our area, we've seen them again, but a different species. So this breeding behavior seems to be distributed in the family.
Okay, interesting. I have another question. So for the animals you collected in the trawls, will anybody be looking at their diet content so that we know what the food web interactions might be?
Yes, to some extent. We have on this cruise we had one PhD student with us who specifically looks at the diet, the food web, and the carbon flux. So doing both diet studies and biotrophic biomarker to see from which carbon sources the carbon fluxes through which ways? Through the food web, specifically with a look at ice algae carbon. And we never throw anything away. So we have a lot of samples, but we don't have the capacity to do extensive diet studies at the moment.
Yeah, certainly. All right, another question from Frank Muller-Karger. Are you doing any ecological modeling as part of WOBEC, and if so, what kind?
For the final results of WOBEC, we are looking at statistical modeling, where we want to use our ecological data to actually look at the spatial structuring of our research area. And we would, if you mean mechanistic modeling, I think that would be the next step that would be absolutely needed in order to, well, for me, it's really a good tool to develop hypothesis and see how the system changes. I'm personally, and I might be wrong, not really confident that you can actually use them to forecast how an ecosystem behaves yet.
Another question, Mike Fadak wondered if the use of animal platforms for ocean observations have been considered. This approach is increasingly being used to monitor EOVs in the Southern Ocean, including the Weddell Sea.
Yes, absolutely. We are in contact with the tracking community. They were not part of our consortium when we applied to this, but we will use their data. They will be part of this WOBEC metadata portal, and I agree that they should be absolutely included in any future monitoring, and we could also think of expanding this.
Anna Carolina Proalta thanks you for the interesting talk. And she's currently working on a project aiming to understand zooplankton biodiversity on the West Florida shelf. And she would like to ask you if you would please repeat again how you did validate the EK80 scattering, as they're applying the same approach, but using lower frequency, which she's starting to think is not the right one.
So this validation is work in progress. So I cannot give you results. There are a few caveats that if you compare tropic and polar ecosystem, is that we are dealing with much bigger animals. So I haven't ever worked in the tropics, but to my knowledge, like copepods, zooplankton is like barely visible. It's more like a microscopic thing, and we can actually see our copepods with bare eyes. They can be over a centimeter. So that also has implications in the backscatter signal. But the principle should be the same, is that we are collecting as much information as possible about the community composition and the size distribution of the animals that we see. We try to do that in parallel, so at the same time as we are using an echo sounder, so we can see how our community is reflected in the echo sounder signal. And something new that we are doing now is, since Polarstern now has a broadband echo sounder, we can use a much wider frequency band, and this will hopefully allow us also to get a better to be able to interpret our high acoustic data better in terms of taxonomy. I'm happy to keep you updated about that. Again, don't hesitate to contact me. I think I forgot to put my own email as a QR code. But you will find me via the RV website, awi.de, and then just type my name in the search field. You'll find me.
Carolina says, yes, she's interested in continuing the conversation. So you will be hearing from her.
Very nice. You're most welcome.
Any other questions from the audience? I'm checking the chat and the Q&A. All right. Well, I think that might be it. Dr. Flores, we all want to thank you again. So very much appreciate hearing your interesting talk.
Thank you so much for listening in.
And that is the end, I guess.
Okay, then.
Or it says we're still live streaming.
I don't know if you wanna, the organizers wanna hang out to give a small feedback after we close the webinar.
Looks like we're closed.
Okay. Great.
Yes, very much. Thank you very much for being with us. It was a great session. I will send you some statistics by email.
Bye.